Good afternoon, everybody. My name is Andrew Braham, and welcome to our first Pavinar of the spring 2013 session. Today's topic will be on different methods of asphalt pavement crack repair. Before we get started on the technical content, there are a couple of logistics that I would like to go over. First, if you can't hear me talking now, I encourage you to check your computer volume and/or your speakers. And if that does not work, go in the Illuminate software. On the upper left-hand corner, you can see a bar that says Tools. Go to Audio, Audio Setup Wizard, and follow the instructions for help. And beyond that, I apologize. One of the difficult things about these webinars is that everyone's computer has slightly different settings and everything. So those take care of most of the questions and problems that have occurred to date. Another thing is you'll notice that I turned off microphones. Sometimes there's a lot of background noise. Sometimes there's extra talking that's going on. So I found it's just easier to turn off people's microphones. But if you do have a question, please raise your hand. And if you again look at the left-hand side of the screen below the participant list, there's a small blue hand with a green arrow pointing upward. And if you click on that button, I will be notified and the group will be notified that you're raising your hand and you have a question. Then you can simply type the question into the chat box, which is just below that icon. And because you raised your hands, I can pause and wait for the question to be typed in, and then people can, and then I can address the question as it's asked. Finally, you will receive one professional development hour for participating in this Pavinar, and that will be emailed to you after the presentation. So today we'll be talking about different methods of asphalt pavement crack repair. And I'd like to thank our industry contact that recommended this topic. If you have any topics you'd like to hear, please do feel free to submit them through the website. So in general, what we'll be talking about today is first we'll just do a little bit of background on how do cracks form in asphalt pavements and then why do they need to be repaired. We'll talk about different techniques that can be used for maintenance and rehabilitation of cracked pavement surfaces. And then we'll spend a little more time talking about the concepts of crack sealing and crack filling. Because when people think of cracks, that's often the type of maintenance that they think of first. So for crack sealing and filling, we'll be talking about some procedures and equipment that are used, and then also some construction tips. And then finally, as I was looking into research on this, there is quite a bit of information out there about a concept called saw and seal techniques, and this is where you actually cut a joint into an asphalt pavement. And this allows you to control where the crack forms and then control the maintenance of that crack almost immediately. So that's something that could be very interesting as well. So we'll talk a little about spacing and depth of those, and then a little bit about the operations in general. So how do cracks form? Asphalt pavements are fantastic pavements. There's a lot of pros and cons. One of the cons is that they are susceptible to cracking. I put 3 pictures of some of the more common cracks, including fatigue cracking, which is caused by repeated and excessive loads, thermal cracking, which is caused by low temperatures, and then also a new type of cracking that's really come to mind in the past 5 to 10 years is top-down cracking. And this occurs when you have horizontal tensile loads applied onto the pavement. Now there are also other types of cracking, including reflective cracking, block cracking, edge cracking, and slippage cracking. But I'm going to be focusing on the, regardless of the type of cracking, we'll be focusing more on how to maintain and rehabilitate pavements that have cracks on them. You can see in general, traffic and the environment are the 2 largest causes of cracking. So yes, asphalt pavements do crack, and they're actually designed to crack. So we have to ask the question, why do cracks need to be repaired? So the concept of pavements, like any other solid, is as the temperature increases and decreases, pavements actually expand and contract with those temperature changes. And when you have what we can call a clean crack, a crack that's not filled with material, that allows the pavement to expand and contract along in a transverse direction. So the pavement's actually moving along with those cracks. However, some problems that occur when this cracking happens is that the cracks can fill with debris, dirt, and other incompressible material, and once that occurs, then the pavement can no longer expand and contract. Also, if you have a crack, some deterioration can begin around those cracks. It's a weak point in the pavement. As tires go over there, there's some deterioration. And then also, especially in our colder climates, if water gets into those cracks and the water freezes, it will of course expand, which would expand the cracks. So that's just a brief intro on why cracks need to be repaired. And it looks like John has a question. So we will, if that's true, we will wait a little bit now, and we'll have a chance to type the question into the chat box. So John, if you do have a question, would you mind raising your hand again? If not, we'll just continue moving on. Okay, thank you. So the question is, he asked the question, are asphalt pavements actually designed to crack? And well, that may have been a poor choice of words on my part. I guess maybe a more accurate statement would have been that as pavement engineers, it is not unexpected to see asphalt pavements crack because of the extreme weather conditions that they're subject to, because of the loads that are applied, because the fact that they're built on these different types of materials. Cracks in pavements, especially depending on what type of structure they have beneath them, it is not unexpected for them to crack. And just because a crack forms, it does not mean we have a fundamental problem with the asphalt pavement. So I probably said that a little offhandedly. Oh, but thank you for the question. So as a continuation of that question, when these cracks do form, it is not unexpected, but once the cracks form, they can quickly cause more problems. So as the cracks fill with debris, dirt, or other incompressible material, the pavement can no longer expand and contract. And when that occurs, then you have new stresses that build up in the pavement, and then new types of deterioration occur. So if the pavement does crack and it's able to expand and contract, and those cracks are not filled, then your pavement can be in a serviceable condition for quite a long time. As I mentioned in the slide before, when that deterioration begins around the cracks, it increases the crack size, and as those cracks become larger, you reduce the ride quality and also the pavement condition. And then finally, when the crack fills with the water and freezes, that causes the crack to expand, and you accelerate the deterioration around the crack. Any sort of deterioration of a pavement is not a good thing. It increases the maintenance costs, it reduces the ride quality. So what can we do in order to address that? So that's just a very general background of cracks and pavements. Thank you, John, for that question, but does anyone else have any questions at this time before we move on to the repair of cracks? Okay, well, thank you. We will continue moving on. This is from a very nice FHWA manual, and I can supply you with the link to that document. I will put it into the chat box. So if you follow the link that I just inserted into the chat box, you can bring up this document, which was created in 1999. And there's actually two parts, a part A and a part B. So if you're interested in downloading it, it took me a while to figure out why there were only 89 out of about 140 pages of this document. There's actually 2 separate files you have to download from that web page. But they provided some basic maintenance guidelines in order to how to not only define cracks, but then also how to judge, well, what can we do about them? So you can see in the upper left-hand corner, you have low levels of edge deterioration, and you also have a low level of crack density. And if you have these events, they recommend that you do nothing to the pavement. But then as you move into more moderate and high levels of edge deterioration and moderate to high levels of crack density, you then need to start considering things such as crack treatments, crack repairs, surface treatments, and also into actual rehabilitations of the pavement structures. So when I was reading this document, I felt that the definitions of crack density were a little vague, the low, moderate, and high definitions, and the document simply said that they're described in general terms and experienced personnel can make reasonable assessments of density. So they're kind of counting on the people being out there having a little bit of experience with judging what would be low, moderate, and high crack density. So what are some of these crack treatments, crack repairs, surface treatments, and rehabilitation? Well, I divided this slide into 2 sections, maintenance and rehabilitation. And what would fall under maintenance would be the concepts of crack treatment, crack repair, and also surface treatment. And then the rehabilitation options would fall under the rehabilitation strategy that we saw on the previous slide. But when we're talking about maintaining asphalt pavements, you think about concepts such as fog seals, slurry seals and microsurfacing, chip seals, scrub seals, which is the picture that you can see on the right. That's actually a picture of a scrub seal. And then also crack sealing and filling. Now, crack sealing and filling is a very big topic, and that's one of the more popular techniques to maintain a crack once it's formed on a pavement, so we'll spend a little more time on that. But I thought I'd give a little overview of those maintenance strategies and also a little brief overview of the rehabilitation strategies, such as putting an overlay on the pavement, full depth reclamation, and then either cold in place recycling or hot in place recycling. So when you're thinking about fog seals, slurry seals, and microsurfacing, fog seals are simply a very light application of asphalt emulsion, and this is where the top of the asphalt pavement becomes oxidized. There may be some very, very minor cracking. If you put a fog seal on there, it does have the ability to fill some of the smaller cracks. Now, if the pavement's a little more deteriorating, if there's a little more cracking going on, you may need to use a little more robust maintenance activity, such as slurry seals or microsurfacing. And slurry seals and microsurfacing are simply a blend of asphalt emulsions, fine aggregates, and mineral filler. And this is placed down in an extremely thin layer, usually less than 1/4 of an inch, and it can also penetrate down into some of those cracks. And the difference between slurry seals and microsurfacing is that microsurfacing includes polymer in the asphalt emulsion. So slurry seals are generally unmodified asphalts, whereas the microsurfacing has the modified asphalts that has some polymer in it. When you're thinking about chip seals and scrub seals, chip seals is where you have an asphalt emulsion and then the chips are embedded into the surface, and this is primarily used for restoring surface friction, but it also can fill some of the cracks. And the picture on the right is more of a crack sealing procedure, and it's called a scrub seal. And this is where a modified emulsion is pressed or scrubbed into an existing cracked pavement. And the material is literally pushed down into the cracks. So if you look on the picture on the right, you can see that the emulsion is being put down by the spray bar, and it's actually being applied at a very heavy level. And behind that spray bar, there's a series of brooms, and there's almost a wave in front of that asphalt emulsion. And that wave is pushed down into cracks, and it's meant to seal cracks. Now after that emulsion has been placed, you can spread a little bit of sand or stone on the surface to prevent tires from picking up the emulsion. But the scrub seals are used to specifically fill cracks in pavements, whereas chip seals and microsurfacing and slurry seals, crack filling is a side benefit and really not one of the more primary reasons that those are used for maintenance. Now if you recall back on slide 10, the next topic under maintenance was crack sealing and filling. And like I mentioned, that's a little larger of a topic, so we're going to talk about that after the rehabilitation. So the first two types of rehabilitation that we'll discuss is you can put an overlay, an asphalt concrete overlay on top of a cracked surface. And this is generally a 1 to 2 inch overlay. It increases the pavement structure so you get a little more strength in that road, and it does cover the cracks. Something you need to be a little careful of though is if you have a cracked asphalt surface and you put an overlay on top of that, there is a high chance that you'll have a reflective crack. So the cracks that are in the existing surface will move up toward the new surface. So that's a risk that you would have to take, and that's something that can happen. Full depth reclamation, where the picture on the lower right shows, is the techniques where you actually take all the surface layer and then some base material, and you literally mix it all together and mill it into smaller particles. And you can bind that together with either an asphalt emulsion, an asphalt form, or Portland cement. Those are 3 common stabilizing agents. And this literally creates a relatively thick, new pavement structure. Now because you're milling all this material up, you are going to remove all surface distressors. So certainly all cracking, but you can even get rid of some rutting. And what this allows is it kind of builds up that structural number of the material underneath the small asphalt surface. And then you're able to put some sort of overlay or a maintenance treatment on top of that FDR surface. And in theory, you're able to have a small increase of structure in your pavement. The last rehabilitation technique that we'll cover is the cold in place and hot in place recycling. Cold in place recycling is very similar to full depth reclamation, or FDR, but it only recycles the asphalt concrete layers. So the technologies are not designed to incorporate any of that base material or any sub-base material. You're only using the material that's within the flexible pavement within the asphalt concrete pavement layer. For the hot in place recycling, the picture on the right there, basically the pavement is heated with these large heaters that are behind semis. It's heated and it can be either scarified or mixed with some sort of rejuvenated agent. So this is taking the top 1 to 2 inches of the pavement, reheating it, putting some more material in there, and then putting it back down, compacting it back down. And this can also eliminate any sort of surface defects, but it does not increase the structure. So up till now, these are some general maintenance and rehabilitation techniques. But as I've mentioned before, crack sealing and filling are by far the most common way to address cracks. So we'll kind of transition now into those areas. As I was doing a little bit of research for this, as I mentioned, there are a lot of internet resources available. And by far the best is from the Federal Highway Administration. So that link on the left, the www.fhwa.dot.gov, that is a link where you can download this report, and there's a Part A and a Part B, or you can simply Google FHWA RD99-147. And I got a lot of the information from that internet source, so it's a very good document that explains a lot of these concepts. What they did though is they divided the concept of cracks into 2 parts. The first is crack sealing, and the second is crack filling. Now for crack sealing, you use this on working cracks. And working cracks are cracks that are moving. So I had mentioned before, sometimes when you have a crack, the pavement is continuing to expand and contract. And those cracks, the space that those cracks occupy, is actually necessary in order for that pavement to be able to expand and contract. So when you're sealing a crack, you want to prevent water or any incompressibles from entering into that crack, but you still want it to be able to expand and contract. So this is a little more complicated than a non-working crack, so it's more expensive and more time-consuming than crack filling. And crack filling is used on non-working cracks, so cracks that are no longer moving, say like longitudinal joints or fatigue cracking. Often with fatigue cracking, the pavement's not expanding and contracting in those very small little sections, but there is still a crack there, and if either water or incompressibles get into that crack, that does create problems with the roadway. So when you do crack filling, your primary goal is to reduce the infiltration of water and any small sort of incompressibles. Now here are some recommended criteria for sealing and filling. This is again from the FHWA report. So you have crack sealing in that central column and crack filling on the right-hand column. And there's multiple crack characteristics that they point out that you should note. The width of the crack, any sort of edge deterioration of those cracks, is there any spalling occurring or secondary cracks, how much annual horizontal movement is there, and then also the type of crack. So you can see for crack sealing, the cracks are generally a little smaller and you have less edge deterioration, but the movement of the crack is greater. And then there's various cracks there that are listed, and you can see there's some overlap between the two types of activities, but thermal cracks and reflective cracks, transverse and thermal and reflective cracks are generally covered under the crack sealing. Longitudinal, reflective, and cold joint cracks are in the crack sealing, whereas for the crack filling, you have longitudinal, reflective, and cold joint, and also some edged and distantly spaced blocked cracks. So again, that's an overview of the repair, and now we're going to move into the procedures and construction for cracks, specifically focusing on that crack sealing and crack filling. I had a comment from one of the participants that's an excellent comment, and it's from Steve Mueller, and he mentioned that cracks should be filled prior to the placement of thin surface treatments. So if you're going to put down any sort of chip seals, slurry seal, microsurfacing, you do need to make sure that the cracks are taken care of before you place a surface treatment over them. And also if there's kind of a large area of deterioration, you may need to patch that. Whenever you put a thin surface treatment on the surface of a pavement, you want to make sure that that pavement is in good condition to begin with, because I think of it as a Band-Aid. If you put a Band-Aid over a small cut, it will heal. If you put a surface treatment over a pavement that's in good condition but needs a little bit of help, it will help out. But if you put a bandage on a broken bone, it's not going to help at all. So if you put a thin surface treatment on a pavement structure that's deficient or that's significantly deteriorated, it will not be very beneficial. So Steve mentioned that many agencies schedule crack and sealing or any sort of patching about 6 months in advance of the thin overlays. And this helps to avoid bumps in the overlay and really helps minimize any deteriorations moving very quickly through that surface. So thank you very much, Steve, for mentioning that. That's definitely a good addition. Now, Daniel has a question. He raised his hand, so we'll wait as he types that in. And Daniel's question is, what is the difference between a crack repair and a crack treatment? And that was in the FHWA table. So that's back on slide 9. So Daniel's question was, here on slide 9, you have both crack repair and then also crack treatment. And to be honest, Daniel, I'm not sure what their official definition of between crack repair and crack treatment is. In that report, in the link that I posted on there, there might be a little more information. But it looks like, according to this table, any sort of crack treatment is a less severe option because you either have lower percentages of edge deterioration and lower levels of crack density, whereas the crack repair has those higher levels of edge deterioration. But as far as like actual definitions, I do not know that. But thank you for that question. Now we also had another question about audio cutting out, and the question was raised, is there a number that I can phone in? I'm not familiar with a number in the software that can be phoned in, so if you're having trouble with your audio, I do apologize, and I encourage you, because you're attending this live, you will get the PDH hour, but I will be posting the recording on in a couple of days, so if you're having trouble with the audio, I encourage you to perhaps try and catch the recording after that is posted. But thank you very much for those. Oh, another question here is, what is the difference between crack filling and crack sealing? Crack filling, my understanding, the question is related to this table right here, the crack sealing versus the crack filling. A crack sealing, you generally have some sort of material that's designed to expand and contract with the pavements moving. So there's silicone material, elastomeric material, but these different types of materials that are actually designed to expand and contract and to seal that off. Whereas with the crack filling, you're not expecting a lot of crack movement. So generally it's a material that's just meant to fill a space, and it doesn't necessarily need to move a whole lot in order to move with the pavement. So crack sealing tends to be made of a material that is able to move with the temperature changes and with the pavement movement, whereas the crack filling is a material that is meant to just simply take the space and not have to move with the pavements. And again, that question was, what is the difference between crack sealing and crack filling? Are there any other questions? Thank you very much for these questions. This is a good way to get more information. But if there's any more questions, I'll take them now. Okay, well, thank you very much. We'll now move on to some more details about the how to treat cracks using these sealings and filling techniques. In general, there are 5 steps that you need in order to treat a crack. The first is crack cutting. The second is crack cleaning and drying. The third is material preparation and application. The fourth is material finishing and shaping. And then the fifth is blotting. And now you'll see here that steps 1, 4, and 5 are considered optional. So they're not necessarily done on every job, but they do add quite a bit to the quality, and also depending on what sort of setup you have, they may be necessary, but they're not required for every job, whereas steps 2 and 3 are required for every job. So for crack cutting, you either use some sort of router or a sawing mechanism. And this is often used for those crack sealings, because with a crack sealing, if you're putting this material down into a crack, it's very good to have a slightly deeper, slightly wider crack, because a lot of these materials, they come in like a tube shape, and those can actually sit in the crack. So you don't necessarily need it for the filling, but it is more required for the sealing. For crack cleaning and drying, because that is required, I'll cover that along with material preparation and application in the upcoming slides. The material finishing and shaping is frequently used, but it's not required. You are putting some sort of material into a crack, and you don't want to make little mini speed bumps. So if you put too much material on, there's a possibility that it will form a little crown, and that has all sorts of potentially unpleasant effects, especially on the riding quality. And then also if you have snowplows in the area, you might end up plowing up your material. So there may be some sort of steps that are required after you apply it in order to make it flush with the surface, or in order to make it where there's nice gentle inclines and declines going across the cracks, which we'll see in a couple of slides. Then finally, the blotting. This prevents potential tracking. The material that you're either sealing or filling, it needs to be placed in the crack, and it needs to adhere to that crack. You don't want the material to pop out right away. Well, any sort of material that you put into a crack that adheres to a crack, it also could possibly adhere to a tire, and that's called tracking. So you want to minimize the amount of tracking that you have, and you can minimize that by using blotting. So starting out with the first step, crack cutting. These are generally performed with either routers or saws, and this is because you do want to minimize any sort of spalls or fractures. When you are cutting into a pavement, there's a chance that you could hit larger aggregates, or you could actually bring chunks of pavement up with you when you're trying to make a nice clean cut, and you really want to minimize doing that. The purpose of cutting a crack is to get clean, straight surfaces, and any sort of spalling or fracture really deteriorates that. There are two types of machinery that you can use, and this is quickly getting out of my comfort zone. I've not used either one of these, but you can use what's called a vertical spindle router. And a vertical spindle is basically what they call a clustered cutting head that rotates about a vertical shaft. And this is the least damaging, it's the most maneuverable, which are two very big pros, but it's also very slow. And when you're talking about potentially shutting down a lane, stopping traffic, those type of things, slow is not necessarily the best thing to have. Another option is using a rotary impact saw. And this is faster, but it does have varying degrees of damage. As you speed up those blades, you will increase the chance for spalling or fractures. Now evidently there are two different types of blades that you can have, and carbide blades do have less damage than steel. For a rotary impact cutter, this is multiple cutter heads that are mounted about a horizontal shaft. And then those cutting heads rotate about that horizontal shaft to actually cut into the pavement. So that's kind of the difference between a vertical and a rotary impact saw. It's important to follow meandering cracks. So if you have a crack going across your pavement and it's going a little bit to the left and the right in the transverse direction, you want to eventually try and follow that crack, because if you put in a straight saw cut along that crack, there'll be some sort of distance between the saw cut and the crack itself, and that could easily pop out, creating a larger deterioration that could possibly lead to a pothole or another deterioration. And at the end of the day, when you're cutting this crack, you want a rectangular reservoir with smooth walls. And in a couple slides I have some pretty nice diagrams from the FHWA report that kind of show the different options you have with making these reservoirs with the smooth walls and then placing material in there. So the first step was crack cutting, and the second step is crack cleaning and drying. There are three recommended methods of cleaning and drying a crack after it's been sawed. The first is air blasting, the second is sandblasting, and the third is wire brushing. Air blasting is just as it sounds. Basically you have compressed air on the job site and you are blowing these cracks clean. It can be done either at ambient temperatures, whatever the natural air temperature is, and it can also be done at hot temperatures. Air blasting is very effective at removing dust, debris, and some pavement fragments. And if you use the hot temperature air blasting, it'll cost a little bit more money. Hot compressed air is more expensive than cool ambient compressed air. But it does remove moisture that's built up in the crack, and then because you're heating the surface a little bit, you can enhance the bonding between the surface and whatever sealing agent you're placing in there. The second option, sandblasting, is more labor intensive. You need to bring sand to the job site and then force that through the cracks. But what it does is it leaves a textured surface. So after you've made your cut, you usually have smooth sides. But sandblasting actually puts little micro texture into the sides, which is, that should be ideal, not idea. But it really helps with the bonding between the sealant material and then the crack itself. This too is effective at removing debris and some loose pavement fragments, but since you're shooting sand into there, it doesn't do as good of a job of removing dust, which you don't want the sealant material to attach to the dust in the crack. You want it to attach to the crack itself. If it just adheres to the dust, then there's a chance it could pop off because there's no adhesion between the crack sealing material and the sides of the wall. And then finally, wire brushing. This is where the wires are performing mechanical contact action against the crack. This is very good at removing debris, but it's not as good at removing loose pavement. And I think this is because it has a much larger force than either air or sand, so you actually have a chance of kind of removing a little bit more pavement as you're brushing the surface. So the next two slides are going to be 12 different ways that material can be placed. So this is techniques A through F, and again the FHWA resource has a very nice description of each one of these. But you can see all of them have some sort of crack, and all of them are filled with some sort of material. So for part A, you have a crack and you simply put material down in that crack, and that's called a flush fill. For the second one, again, you have a crack, you put material in there, but then you also put what's called a simple band-aid on top, which is a very small, thin layer of sealant material that covers kind of both sides of the crack. And this helps keep water out and keep other incompressibles out. You can have either a simple band-aid, which is a slightly wider cap, and then number C, you can also, or letter C, you can also see has a smaller cap. So there's different options available with that. For the standard reservoir and flush, which is part D, this is where they actually cut into the pavement and they make a reservoir. And you can see that these sides are square and it's larger than the crack itself. And that allows you to put a good amount of material into there and really have a nice square surface that can keep those waters and incompressibles out. That square reservoir can also have a band-aid on top, or it can have a cap. I assume, I don't see that on here, but there's also different depths that you can go to. So there's these different types of techniques, and there's quite a few pros and cons with each one. So you can also have a deep recess with that band-aid on top of it. You can have a more shallow reservoir with or without a band-aid. And then looking at J in the lower left-hand corner, this one is of particular interest because it has what's called a backer rod in there. Everything up to J, the deep recessed, the shallow reservoir, the flush fill, the capped, all of those are simply putting a sealant material in. But there are also materials, and these were those tube shapes I was talking about, where you can actually put a backer rod down into the crack after cutting it. And this is more of a elastic type material that comes in long sections. It kind of looks like a garden hose, but a little smaller. And you literally just place that down into the crack. It's solid, it's not hollow. But instead of having to fill a crack with something, you simply put this material down in there, which can be a little more, it can be a little cleaner than taking out, heating up sealant, and placing sealant on the pavement. Now you can have that a little recessed, you can have it flush with the pavement, and then you can also put a little band-aid, as they call it, on top. So we could probably spend the next hour talking about how these different types are used, the pros and cons. I just wanted to give you a broad overview of the different options that are available. So that was the second step, the crack cleaning and drying. Now we'll talk a little bit about the material preparation application. You saw the 12 different types in the previous 2 slides. And we will talk a little bit about what sort of variables that go into here. And variables can include things such as what type of material you're putting in there, if a bond breaker is necessary, what is the size of your job. With those larger jobs, sometimes those backer rods are more convenient. You can put a lot more material down more quickly with less mess. You also, if you have any sort of constraints on preparation time, crack sealing and filling occurs on all sorts of different types of roads. Sometimes it's on interstates, sometimes it's on residential streets. So those type of things will determine what type of material you will use and what the process you will go through in placing the material. Obviously, since we're in roads, the ambient temperature is very important. So whether it's really warm or really cool, there are a whole bunch of different options on there. And finally, safety as well. At the end of the day, there's a lot of people out there on the job, on live roads often. So depending on what sort of safety is available, that's a big consideration as well. After you are done with the material preparation application, you do need to think if it's necessary to finish and shape that. So if you are applying the sealant in a wand, that usually comes out and then sometimes it kind of overflows the crack a little bit. You can put an attachment onto your wands, or you can have like an industrial rubber squeegee, but what that does is it kind of scrapes the surface and makes it an even application. And like I said on the previous 2 slides, there's a lot of variables that go into here, and if you guys are interested in those variables, I'd recommend submitting that as a future topic. But I wanted to wrap up the procedures in construction before moving on to the saw and seal technique. So the last step in the crack treatment is the blotting, and the first time I saw this I thought it was pretty funny. You can either use sand, you need a truck for that, but you can spread the sand across the crack sealing material, and that will reduce the tracking of traffic going over there. Or, the part that humored me, is that you often see toilet paper being used. And this is a pretty effective way of making sure that tracking doesn't occur. You can simply attach toilet paper to a long-handled modified paint roller, and someone fills the crack, and right behind them, someone rolls toilet paper down onto that crack. And that really does reduce the amount of potential tracking from traffic. So that's kind of a little introduction to the procedures in construction, and I want to spend a little time talking about sawing and sealing, but we did have a question on slide 22. And the question from John is the sealant placed on top of the backer rod? According to this diagram, it appears that there are two, J and K are both cracks that have backer rods in them, and they do not appear to have any sealant in there. And L, it appears that you have this Band-Aid on top. Now it's my impression that backer rods are used as a replacement for sealant. So if you put a backer rod in, you may not need sealant because that backer rod prevents any water from infiltrating or any sort of incompressibles from infiltrating. Now, but it appears that this Band-Aid that's on top, that Band-Aid could be a sealant type material. So I don't want to say that you never use sealant on top of a backer rod, but it appears that these backer rods are primarily used in place of sealant. And John's follow-up question was, what are the dimensions? And I assume you're meaning what are the dimensions of the sealant in the backer rod. And I believe that these are just some some possibilities for dimensions. I think that quite a few DOTs have extensive guidelines for their own crack treatment. I found guidelines for Illinois, for Texas, for Georgia, for Minnesota. So quite a few states have their own guidelines. I think that FHWA just published some general ones. So the next question from Judith Shaw is, what about organic materials in the cracks, specifically in residential areas where plants and trees can begin growing in the cracks? How important is it to remove all the organic material as opposed to just removing dust, dirt, and debris? And that is extremely important. Anytime you see any sort of organic material or plants growing in your cracks, you know that your pavement is due for some maintenance and/or rehabilitation. But if you are going to either seal or fill your crack, you need to make sure that all that organic matter is removed. Because if you go ahead and place any sealing or filling material with that organic matter, as the organic matter decomposes, assuming it will die because it's been covered with this material, as it decomposes, it will actually weaken the structure of the sealant and literally leave gaps and voids in that sealant. So if you're facing a road that has organic material in it, you do want to make sure to get all of that out of there and have just the pavement surface before treating your crack. And it looks like we've got a couple more questions here, so I'll wait as those questions are pushed through. Okay, as I mentioned, if you do have a question, thank you for raising the hand, and then you can simply type the question into the chat box below where you clicked for the questions. So John's next question, or he labeled it as a compliment or a comment, is that the backer rod is at the bottom and the sealant is placed on top, kind of a reservoir and flush. And I'm sure that's true. So for example, in letter K here, the backer rod is placed on the bottom, and then there's a small amount of sealant that's placed on top. And then in L, you have the backer rod on the bottom, a small amount of sealant placed on top, and then that Band-Aid that's placed on top. But I do encourage, if there's anyone on here with more experience on this material placement comments or material placement concepts, please do feel free to chime in, because I think that that's one of the good things about these webinars, is that we can bring experience in from all around the country. Okay, so moving on here, I would like to just finish up here with the saw and seal. We're getting a little close to 1 o'clock. I know that you're all very busy, so I'm thinking maybe I can go through this saw and seal, go through a little bit of logistics toward the end, and then I can open it up for more questions. And if people stay past 1 o'clock, that's fine, but I want to make sure to get through the content before the 1 o'clock time period. So saw and seal, this concept came about because traditionally many agencies just wait for the cracks to form and then try and solve the problem. But people, some different agencies have asked the questions, what if the cracks are actually introduced to the asphalt concrete pavement immediately after construction? And this is very similar to the concept that we use for rigid pavements. What would happen is you would introduce this crack, you would immediately seal it. And this would give you more control over both the location and the quality of the cracks. If you immediately saw a crack into a pavement, you're guaranteed to have those nice, clean, square sides, and you don't have to worry about a meandering crack or any concept like that. So there are quite a few potential pros to this concept. And multiple states have done research in this method, but again, as I do quite often, I'm going to turn to my good friends in Minnesota. Minnesota has an excellent website with many reports. One of them is on sawing and sealing. So if you simply click on that link I just put into the chat box, you can download the report that I'll be talking about over the next couple of slides, which was produced in 1996, but still has some very good information in it. Essentially, Minnesota began experimenting with sawing joints back in the 1960s, and since then, over 50 sections have been constructed, and they've constructed these sections on various pavement structures, including asphalt concrete or HMA over PCC, Portland cement concrete, HMA over HMA, and then on also new build HMA sites. So a very large range of different types of situations where you might expect to see future cracking. And in 76% of the sections that you could say pre-treated with sawing, the formation of the cracking was controlled by actually sawing the joints. So 3/4 of the jobs they were able to dictate. Minnesota was able to dictate where those cracks would form, and they were successfully able to control cracks in just those areas. They found out that in these sections where they were unsuccessful, so that 25% that they were unsuccessful, these saw cuts were not deep enough, and the existing joints, so this would be on the HMA over PCC, or HMA over HMA, the existing joints were either very badly deteriorated or they were poorly relocated. So a saw cut could have been made over a location that did not have a crack in the existing pavement, so that crack simply reflected up anyway, and you had both the saw cut and the reflective cut in the same section. So they felt like if they were able to make a deep enough saw cut, and if they were able to place the saw cuts in the proper location, they would be able to increase that formation of cracking successfully. This is a little schematic of how the saw and seal works. So up in Minnesota, or down in Minnesota, depending on your geographic location, the most common type of crack is a transverse thermal crack. It gets cold in Minnesota, so the pavement wants to shrink, it contracts, and thermal cracks occur. And Minnesota found that 95% of their trunk highway mileage has thermal cracks. So this is a significant problem that they have up in Minnesota. The concept of a thermal crack is that it occurs at a maximum stress level on pavements. So if you put a saw cut into a pavement, in theory you're forcing the maximum stress to occur where that saw cut takes place, because you have the smallest area for that crack to form. Instead of cracking through, say, a full 4 inches, it only has to crack through 1.5 to 2 inches. So those saw cuts reduce the cross-sectional area, and you'll force the crack to form there. You need to be effective with cutting these joints, the saw and seal joints. You want it to be deep enough to ensure the crack will occur at the saw joint. If they're too shallow, you could have a crack at a different location. And they found that a minimum of 1/3 of the total asphalt thickness, or 2 inches, whichever is greater, is a pretty good rule of thumb for how deep to cut that joint. You want to make sure that the crack spacing that you're putting in, your sawing spacing, is close enough to ensure that the tensile stresses are not too high away from those saw cuts that you're making. So if you put the saw cuts too far apart, you're still going to get thermal cracking in between those saw cuts. So they found that in sections with 100-foot joint spacing, they had 14 times more cracking outside of those saw cuts than with the 40 to 60-foot joint spacing. So they went down even a little further, and they recommended that you insert a saw cut every 30 to 40 feet on new pavements. And I just summarized about 20 pages of the report in those 2 sentences, or 2 little bullets there. So there's a lot more detail in the report, and the link's on the left. But in general, 30 to 40 foot spacing on those new pavements, and about 1/3 of the thickness is what they found for the crack spacing and the crack depth. They also found that the timing of the saw cut was important. If they cut that pavement less than 24 hours after placement, aggregates were often pushed out and they were actually not cut through, and this could lead to spalling. So they recommended waiting about 48 to 72 hours after placement. They also found that saws that downcut were much more effective at preventing spalling, because that upcutting, if the saw is rotating upward as it cuts the pavement, you actually can tear up the joint edges. They found out that 2 passes resulted in poor results due to the misalignment of the successive passes. So depending on how thick you need that crack, it's better to do it in 1 pass, because then it's all done at once. And then finally, the reservoir shape is a 1/2 inch wide by about 5/8 of an inch deep. Now, of course, one of the biggest things that comes up is what is the cost. Now, I do want to remind you that this was put out in 1996, so the costs are probably a little outdated, but it gives you a basic idea of what you're expecting. They found that the silicone sealant did not work very well, and adhesion is the main problem when keeping joints sealed. And this can be minimized by using softer sealants and increasing cleaning operations. And the average cost in 1996 was about $1.65 per linear foot, or if you're assuming 2 lanes are about 24 feet wide, at about 1 mile, that's about $3,600. So you can kind of compare that to your standard sawing or joint repair to see if it's worthwhile to do that beforehand. Now, I do have a comment from a MnDOT employee saying that this report was published in 1996, which is prior to the widespread implementation of the super pave binder system. So the proper PG binder selection for those very low temperature and thermal cracking susceptible areas should already greatly decrease the need for this techniques. So if your state is concerned a lot with thermal cracking, using the correct PG binder does decrease the amount of thermal cracking significantly, which could decrease the effectiveness of this technique. However, I do think it's interesting trying to be proactive versus reactive in controlling where these crack forms. And as a researcher, those type of things are just very interesting to me. So in summary, I'm going to go over a little bit of logistics and then go to the final slide. Like I said, it's about 1 o'clock, so if you have to take off, I understand, but please feel free to stick around for more questions. Your professional development hours will be emailed to you after the presentation, no later than this Friday. If you haven't heard from me by this Friday, please feel free to send me an email. You can also rewatch the Pavements through the website. I've gotten a couple messages showing that there's been some trouble with the audio. I apologize about that. But you are able to rewatch the Pavements with the audio through the website, and that will also be posted no later than Friday. If you have any topic suggestion, please feel free to submit that. This spring, there are 4 Pavements, and 3 of them are on topics that were requested from either industry or agencies. So it's fun for me. I learn a little bit about a new topic, and also I feel that these are for the community. So whatever you guys are interested in, I'm willing to dig into it for an hour presentation. The next Pavement will be Tuesday, March 5th at noon, and it will be on pavement management systems, and it was requested by the Virginia Department of Transportation. So that's what I have on the summary of different methods of asphalt pavement crack repair. Like I said, it's 1 o'clock, so if you have to take off, I understand, but if you have any questions, please raise your electronic hand, type the question into the chat box, and I'd be more than happy to stick around until those get answered. But thank you for joining me, and hope to see you on March 5th.